Hi there. These are the Chapter 4 notes, and the main topic of Chapter 4 is the periodic table. Now, the first thing I want to talk about is the fact that it is called the periodic table of elements, not just the table of elements. And the reason we call it the periodic table is because it has periodically repeating patterns. And you'll see that a little bit later in the notes. Couple terms here that I will use throughout this unit. Groups and periods. Groups are vertical columns on the period table. Periods are horizontal rows on the period table. I'm going to go through the notes a little quicker than normal because I think you can read them for yourself. I don't need to read them to you. One thing we've talked about already is the fact that the rows in the periodic table correspond to the energy levels in the atom. So calcium is in the fourth row, so it has 4 energy levels, or 4 rings. One thing we're going to talk about this chapter is the columns correspond to something, and it's the number of outer electrons. When two atoms come together and bond, and we'll talk about that in chapter 5 and 6, the things that touch, the parts of the atom that touch are the outer rings. So we don't really care all that much about the inner rings of an atom. We care much more about the outermost ring. And the outermost ring has a special word that we used. It's called the valence ring. So valence electrons are the electrons in the outermost energy level, or outermost ring. And the number of these valence electrons determines a lot of the chemical properties. So we're obviously interested in it. Now, writing the electron configuration for the element will show the number of valence electrons. But I think it's easier just to remember this pattern. The first column here, they all have 1 outer valence electron. The second column, they all have 2. You skip the D block, this middle section. The next column has 3, and then 4, 5, 6, 7, and 8. Now the exception in this last column is helium. Helium can't have 8 because it only has a total of 2. And if we think about it, helium is in the first row, so it has 1 ring, and that first ring is full with 2 valence electrons. We talked about that last unit. And since it's full, it's not going to get any more. It doesn't want 8. It's fine with having 2. So this is one pattern that you're going to want to remember on the periodic table. And I just think, my mouse, here we go. 1, 2, skip a few, 3, 4, 5, 6, 7, 8. And then just remember helium is a little different. And it only has 2. So you want to remember that pattern. And we can see that if I pick, let's see here, let's bring up periodic table real quick. If I just look at lithium, beryllium, and boron. So lithium, is that right? One second. Okay, sorry about that. So if I have lithium and I have beryllium and then I have boron and I have carbon, if I write just the very end of the electron configuration for those, lithium would end in 2s1, meaning in the second energy level, there's 1 electron. Beryllium would end in 2s2, meaning, again, in the second energy level, there is 2 electrons. Boron would look like 2s2, 2p1, so 3 valence electrons total here in the outermost ring for boron. Carbon, well, that's not right. Ignore that. 2s2, 2p2. So that's a total of 4. So you can see this pattern just continues. And if I look at lithium again, it's 2s1. If I look right below lithium, that's Na. that electron configuration would end in 3s1. Right below that, K, that ends in 4s1. So you can kind of see how we get this pattern here. 1, 2, skip a few, 3, 4, 5, 6, 7, 8. You could write out all the electron configurations and see that pattern, but I could just take my word for it. That pattern works. Now we're going to use that pattern to draw these things called Lewis dot diagrams. And you may have seen this in 9th grade, you may have not. It's not a big deal, you pick it up pretty quick. So if we have H, and we have C, A, and we have F, and we have neon, and we have, that's not what I wanted to write. We have carbon, and we have nitrogen. So what I'm going to do is I'm going to use that pattern that we just learned, and this pattern will tell me how many dots to put around the symbol. So hydrogen, we find hydrogen. Hydrogen is right in the first spot, so it's in the first column, so it gets 1 dot. Calcium is in the second column, and it's going to get 2 dots. If we find fluorine is in the 7th column over here, so it's going to get 7 dots. And you're going to want to watch how I put the dots on there. You always start 1 dot on the top, and then you can go around either side, clockwise or counterclockwise, I don't care. 1 dot on each side. Now that gives us 4. And then what you do, if you have more than 4, you start pairing them up. And here we're going to have a total of 7. And they're paired up around on each side. So top, side, bottom, side. Here we have a total of 7. Ne, neon, is in this last column here, so it gets a total of 8. And I'm going to do that same pattern again. 1, 2, 3, 4, 1 on each side, and then go around and pair them up. Now notice that the way these are orientated. The top and bottom, they're kind of side by side, and on the sides, they're on top of each other. That kind of implies that these are all in the same ring. So if you had done it like this, I would mark that wrong in the test. Yeah, you got a pair here, you got a pair here, you got a pair on the side, pair on the side. But again, what we're trying to imply here is that these are all on the same ring. Well, those are on the ring, but then these 2 random ones are out here. So make sure you orientate the dots in this way. Carbon is in the 4th column. So 1, 2, 3, 4. And lastly, nitrogen is in the 5th column here, sorry. And so 1, 2, 3, 4, and then I go around and start pairing them up. So that's what nitrogen will look like. Why don't you try some on your own? Try O, P, K, A, L, B, R, and X, E. If you want to pause the video right now, try those, and then when you're done, restart the video, and I will go over those. Okay, so let's go over these. I'm going to bring up periodic table just so I can see that. Yeah, okay. So we find O, oxygen, 1, 2, skip a few, 3, 4, 5, 6. So oxygen's going to get 6. 1, 2, 3, 4, 5, 6. Again, if you want to go counterclockwise, clockwise doesn't really matter. Phosphorus is going to be 5. Potassium, K, is just 1. Aluminum is 3. Bromine is 7. Whoa. 1 second. Okay, I don't know what happened there, but Start it over here real quick, and bromine is going to have 7, I said, right? 1, 2, 3, 4, 5, 6, 7. Xe will have 8. And since I know they'll have 8, I can just kind of fill them in pairs. Remember to orientate them correctly. And there we go. Hopefully got those right. So continuing on with the notes, there are major kind of categories of elements, and they are metals, nonmetals, and metalloids. And we've talked about this before, how we tell a metal from a non-metal. It's that squiggle line kind of on your handout periodic table. There's kind of a bold line here, and that's your line between the metals over on the left, and the nonmetals on the right. Now there's one exception. Whoa. One exception, and that exception is hydrogen. Hydrogen hangs out with the metals here, but it is not an actual metal. It's a non-metal. Hydrogen is a very special element. Doesn't necessarily play by all the rules of some of the other elements. So hydrogen's hanging out with the metals, but the majority of the elements on the periodic table are metals. The nonmetals are over here, and including hydrogen. And then some of the metals along that border are what we call metalloids, or semiconductors. Kind of have some properties of metals, some properties of nonmetals, are kind of in between the two. And then these down here, the F block, fit in up here, and they're part of the metals also. So the major families of the elements are shown below. I'll kind of let you just read that. You may be familiar with some of those from 9th grade. If not, you will want to know these different families and where they are. Ions and the octet rule. We've talked a little bit about this last chapter. We defined what an ion is. An ion is an atom with a charge that got a charge by either gaining or losing outer electrons, valence electrons. Now, this is a very important concept in chemistry. And I just want to remind you, we talked about this last unit again, that the little charge here is kind of like opposite. 1 plus actually means that you lost 1 electron. 2 minus actually means you gained 2 electrons. Remember, electrons have a negative charge, so if you lose negative charges, you're going to have an extra positive charges, which makes the atom positive. If you gain negative charges, you're going to have extra negative charges, which makes the atom negative. Again, the trick is it's just kind of opposite. Now, this is something we're going to be using for the next at least a couple chapters, something called the octet rule. And that says atoms want to gain or lose electrons according to the octet rule. The octet rule says that they want either 0 or 8 valence electrons. So they want to be full or they want to be empty. And anything in between, they're not all that happy with. Duet rule. That's kind of an exception because helium and hydrogen, well, they can't have a full 8. So they want 0 or 2. He already has 2, so it's happy. But this is a very important concept, at least for the next couple chapters, and throughout this course, is the octet rule. This rule that atoms want to have 0 or 8. And they'll go to whichever one they're closer to. Like in this case, calcium. Calcium has 2 outer electrons. Well, it's closer to 0 than it is 8. So it'll lose those 2 electrons. Nitrogen has 5. Well, it's closer to 8, so it'll gain 3 instead of losing 5. And it looks like this is a good stopping point for the notes, and I will continue the rest of the notes in a second video.